That's my, is that yours?
Yeah.
Okay,
Back
we're
up.
good then.
No, you can stay right there, as a matter of fact, that's exactly where we need to be.
Okay.
So, and by the way, here's a perfect example, trying to present this program and Andy kidnaps the thread, right? So anyways, Andy, I'm gonna come back to pick on you. Along the way to figuring tonight out, we had some discussions on what should we measure, what should we present, and so on. I was all over this return loss thing. Return loss is something that the engineers, the RF engineers love to talk about, is return loss. In the ham world, what do we use?
SWR.
SWR. They're mathematically related, so you're really talking about the same stuff. One of the things that is interesting about those two is, I think, you know, SWR, you're looking for
Low.
yeah. And a return loss is just the opposite, the higher the better.
There's more to that.
Sir,
There's more to that.
oh, I can depend on you.
It really should be a negative value.
Okay,
So you should have minus dB. If you have 0 dB, everything's coming back.
okay,
The lower you go, the more of it's being absorbed by the load. It
Yeah.
should be a negative. But people drop, when they're talking about return loss, they drop the negative sign in front of it, which adds to the confusion. How is loss good?
yeah.
It is a
Yeah, that's
misnomer.
right.
It is a
When you
misnomer,
think-
and it's just a matter of a sign that's thrown into the equation just for convenience. I'd like to meet the guy that named that.
So, what we decided to do tonight was to worry about the something called insertion loss, which was neither one of the ones I talked about, and power loss. I think Ed is gonna do, you're gonna do SWR also?
Yeah, it'll do,
Okay.
SWR forward and, reflected power.
Okay, so we need to figure out what the heck they're doing here. Next slide there, Frankie.
Let's see if I'm doing it right.
So turns out return loss is a measure of the amount of signal power reflected back towards the source in a transmission system. Okay, I got the dot from Ed. SWR and return loss are mathematically related, and return loss equals, who's got their scientific calculator? It's okay. I'm just full of jelly. It's hard to see, but here's a couple examples of incident. What is incident, by the way? I don't understand what that is. Go ahead.
Put your power in. Put your
Power
in
down
the-
line.
In the transmission line, that's. the power.
Okay, what's reflected?
What's coming?
Power coming back.
Okay, or the return. All right, so if you have an incident power of 100 watts and you have 1 watt of reflected power, that will give you a return loss of 20 dB. And you'll help me out on signs here shortly. Should it be a negative 20 dB?
Because when you look at the way the graphs work, yes, it should be, but
Okay,
don't worry about it.
all right, I won't.
Just understand that
Somebody probably-
minus 20 dB is better than 0 dB
Yes.
with return loss.
Okay, so the next one is here, what if we had 100 watts of incident going down the line and 10 watts is coming back? Our return loss will now drop to 10 dB. So that the whole point here is that the higher numbers are the better thing. Do we beat that horse to death? Okay, well, the good news is we aren't gonna do return loss. We're gonna concentrate on insertion loss and SWR. Frank, I could use the next slide. Actually, go, that's good, right there. Whenever a signal travels through because Mark said, hey, I'm gonna do insertion loss, and I thought, well, okay, what's that? When a signal travels through a component or system, there's always some loss of power due to a number of reasons. This loss occurs while a signal is traveling through a component or system and is called insertion loss. And guess what? Also measured in dBs.
And is that negative?
I don't know.
No.
That is negative.
Stands to reason because it is a loss.
Right.
Okay, So, what are we gonna measure tonight? Ed, make sure I'm not lying here. You brought along a whole bunch of stuff, coax from looks of it. You brought along a power meter.
Yep.
And you got a camera on the power meter.
Yep.
And so at some point, Frank, I'm done with the PowerPoint, so if you wanna switch over to showing, Ed's camera there.
Andy's got his finger in the air.
I don't think you have to worry about the negative sign with insertion loss, because when they take the ratio of input power versus that, it is a declining number and it automatically shows up as negative dB.
Okay,
So, I mean, the mathematics takes care of that. You can't forget this. It will take care of it for you. If I remember my math.
you put your terms in correct.
Yeah.
Yeah.
Because
Okay.
it's a ratio. And it's a ratio below. Between 0 and 1.
Yep.
So,
So let's see here, Ed brought a bunch of coax, power meter, he is gonna connect the coax to a dummy load, do I have this correct?
Correct.
Okay, Mark went along his VNA, Mark, could you hold up your VNA?
It's right here.
And strangely enough, he also has it connected to a computer.
I do. And at some point, we can actually show the computer screen on the big screen. If Frank will allow that.
Uh-huh. So, when we measure insertion loss, Mark, I'm thinking. Like if Ed was measuring power, we'd have power in, we'd have a reading, we'd have power out, we got a reading, and if out's less than in, you have a loss.
Very good.
Okay, but what do you do with your VNA?
Well, what the VNA does, in the VNA, I can actually run a test on a component or a system. I can provide a suite of frequency ranges. In this case, I'm going from 3 megahertz to 450 megahertz. I'm applying that signal to a component. In this case, the component is a 150 foot spool of RG8X cable. And what the computer, what the VNA is looking at is the output of the cable. The signal goes into one end and then it comes out the other end. And the VNA measures the signal that arrives at the output of the cable. And it graphs it. We can see the frequency and we can see the signal strength in decibels.
And you're gonna display these as a plot on a chart?
Yes, I am.
Okay,
Yes, I am.
and,
At the appropriate time.
at the. Okay, so, Andy, back to you. What's the scattering parameters, S21, you remember what that is?
I'm not an RF designer, I'm an amateur radio
Okay.
operator, but I had.
What is this? What now?
I had to live in that, and I don't, I know where to look them up. So,
And
that's a modicum of intelligence, it's not way up here, it's somewhere down here.
be honest
For
with
the
you,
scattering
I
parameters.
can't remember whether S12 or 21.
No, I don't think that they go that, it's S11, S10.
Well, this will be an S21 measurement.
S21,
yeah.
The
And the point-
VNA has two connectors, one's labeled 1 and one of them's labeled 2. And the 2 indicates where the signal is coming from, and the 1 indicates where it's going to.
So you actually have your hunk of coax connected across the VNA.
I do.
Okay, in that case, I'm gonna shut up and Ed, Mark, it's on you, baby.
Okay, so as far as showing the loss, as far as loss of power on the different coax, I have a 991A. I have two frequencies programmed into a 2 meter. I have it set for 146 flat, and then for the 440, I've got 446. And we're going to use those two frequencies at 50 watts so we can see the difference. So right now, oh, we
I'll
lost
get
it.
it in a second.
Yep.
There
So
we go.
right now I'm going from the radio to the SWR watt meter, and then I'm going to dry 1.5 kilowatt dummy load. And the reason I went with a larger one, so again, if it started to heat up, it was a smaller one, that would actually possibly cause the SWR to go up. So, I can put 50 watts in this all day, it's not gonna affect. So, who would like to write down some of our results while we're doing it? Anybody?
I got it.
So. Our baseline is gonna be, my setup. We'll do 2 meters first. Ready?
2 meters.
Yep. So, our, SWR is, 1.08. Forward power is, 51.4 and reflected power of 0.15.
51.5.
Okay,
And what was the last?
which one did you need again?
0.15 was the
Point-
reflected.
For the reflected power.
You bumped your camera there.
Oh, yep, sorry.
There was one in the middle. What was that? The SWR was.
Yeah, so this top one's SWR.
Okay,
Oh, I'm sorry, the bottom right is SWR. The top big number is the forward power going out.
just the two numbers?
It's 3.
There's 3: forward power, reflected power, and SWR.
All right, I have SWR and forward power.
And then reflected power.
Yeah.
So what was that frequency of?
That's at 146 000.
And that's into the dummy load.
Mhm.
And that's into the dummy load. Make note of that, Dave, at the end of it.
Yeah, and we're also using for our short jumpers, it's RG8X, they're 2 foot. This isn't a lab, so it's not 100%.
So,
What was the middle reflex?
Was it was
0.15.
0.15.
Okay, sorry, I'm the dummy load today.
Okay, that's all right. So now, because,
The forward reflected are in watts, by the way.
yes,
is this on the connected to the input of the cable or the output?
This is on the dummy load.
on the W.
I'm asking where the meter is connected.
So,
Between the radio and the dummy.
yeah, so,
Okay,
transmitter. And that goes on the top part, and the bottom one is our dummy load.
and
So,
so basically you're looking at, I'm gonna say 1.5 or 2 feet of cable over to the dummy.
yeah,
Right.
So,
Okay, and
two,
those, okay,
so a little bit of loss, but not much to speak of. All right, so let's go to 440. Okay, and that's 446. You ready?
446. 446.
Yes, 446
The 440 band, but 446.
Yeah, yeah. or 77 meters.
77.
Okay, so that's let's climb it up a little bit. Because again, when you look at the specs on RG8X, it's not made for 440 very well.
yeah, it shows up.
Yeah, so it's climbing. Let me unkey it there. So originally we were at
Give it to us again.
Yeah.
Make a note forward.
just make it 448. SWR is 1.19, and the reflected power was pretty constant at 0.19. Okay,
And that's also on a dummy load.
yeah, so when you look at the specs on the on every piece of coax, there's cutoff sheets. Most of my coax is DX Engineering, and actually this here we have 125 foot. Mark has some 400. We'll go ahead and do this one first because we'll be comparing 125, 125. I got a little barrel connector. That's not going to affect it that much. And then we'll do the RG8, do the same thing.
You're gonna be a short jumper out, and put that in.
Well, no, so what's coming out of the radio. Believe it or not, I screwed this up originally. So in your shack, when you're going from meters to tuners to amplifiers, you need to make sure you get your coax on the right plug. Yeah, and that's easy to screw up. Okay.
So you're putting a big chunk of coax between the SWR meter and the dummy look now?
Meters gonna be towards the end. Between the radio and the SWR meter.
Between the radio and the SWR meter?
Yeah, so I'm gonna be hooking the one coax
To the radio. The meters.
to the meter, and the other one's gonna go to the transmit, and it'll actually show us how much we lost.
Oh, I see what you're doing.
In the cable. And where it's gonna be really prevalent is when we get to the thinner coax.
So in essence, he replaced a short jumper with that.
So now the coax is.
The jumpers.
Yep, so we'll go back to,
What is the coax? So it said,
so this is actually DX. This is DX 8U. So, and I have some other stuff like old Tandy. A lot of the old 8U was, the velocity factor was like 0.66. DX greatly improved the shielding on this. And I'll tell you here in a second, because I can't remember what the velocity factor is. So it's a little bit better. When you look at the specs, this is actually better than RG213, but RG213 has a better outer jacket for UV, and it's also direct vary. Correct.
Yeah, it's direct vary.
And that's the coax they recommend for antenna rotors, because it'll take up
Nice.
that. Tell you here real quick what the velocity factor for that 8U. It was 0.81 compared to the old RG 8U had a velocity factor of 66. But this is DX Engineer improved their parts of that coax when they made this.
foam dielectric.
It has a foam dielectric, and that's what helps instead of a solid. Correct.
But not rated for direct vary.
Correct. So it's good for above ground.
Or in.
This is
drainable
RG8U, DX Engineering. And I'm gonna do 2 meters first, just like I did, and then I'll go 440. So we're on 146 flat. Okay, you ready? So you can see the drop, we're at 29.9 forward. And we've got reflected 0.08. SWR is 1.07.
So the SWR went down, the reflected went down, but there's a loss.
Mhm.
And what was this?
So this is 100 foot. So if you look at that frequency, give me a second. My eyesight isn't good, so. So at 150 megahertz, this coax, and again, we've got 125, not 100. It has a loss of attenuation of 2.2 dB.
That's a little less than half. So
So 3 dB would be half.
how many watts did you show this time now?
So we're putting 50 watts in,
Yeah,
so
you get
20
29.9.
29.9. Yep. Yep.
So that's
And
pretty.
that's where, if you had a long run, that's why you want, and we brought some of the better, and I was gonna show this around. So this is DX Engineer, I'll pass this around. This is the DX 400 Max. It's kind of similar to LMR 400 Flex. And then Mark brought LMR 400, which has a solid conductor, and this is LMR 600, I believe, Flex. Yeah, ultraflex. Actually, my
But by the
garage-
way, shameless plug, okay? Used to do DX engineering coax a lot. Had some issues, hopefully in the past, but now ABR, Mark Haverstock turned me on to ABR Industries, which is US based and US manufactured. ABR Industries puts out their 400 and 240 series and 600 series, same as LMR, as good, maybe better. And the price is right. So there's multiple sources for good coax. ABR being one of
Radio Shack, not.
them. Man,
And I have some of the old Radio Shack. Like I said, when you looked at it, the braid was real loose. So the shielding wasn't that great. And there was a time, this is a factory jumper. There was a time Radio Shack was not soldering the ground. They were pulling it back and they actually twisted it on to make the connection. And if you look at that, if you look in the center, they did not shield the ground. So that's the problem. If you lost your ground, your SWR is going to go up. And I can pass two more around. This is some of the old Radio Shack, and I'm going to tell you a story about that. So this is LMR 240. So we had a ham. This is RG8. Again, that's Radio Shack used to crimp.
you mean RG 58?
58. What did I say?
Hey, that's all right.
Yeah. And this is LMR 240. So that yeah, so that has a solid conductor, a little bit different. But Mikey Austin, KC8WX, they sold another ham. They put up a short antenna and they used 240. He was a lot of static because again, he wasn't getting the receive, getting in the repeaters. He wasn't getting in, but the coax he had a crimped center, not a center pin. His tram got water into it. It actually went into the coax and actually shorted out the coax. So when I went up there, we ended up putting a different antenna. I actually put up RG 400 max, and it's between night and day. His receive's good. He's getting into all the repeaters. Again, he was losing a lot of his power going to the antenna. So having good coax does make a difference. So let's go. You ready for 440?
440.
Okay. So there's 440, and again, this is 125 foot.
Yeah, look at
So
that.
so we're down 13.56. Reflected is 0.05.
So what's that saying is the 13.5 watts is getting to the antenna when you're putting in 50.
Yeah,
Yep.
ugly, isn't it?
Mm-hmm.
What was the SWR 120?
1.15.
And the reflective is 0.205,
Correct. Which,
looks lower, but really isn't.
and that's where when you have lossy cable, if your antenna SWR isn't good and you throw a lossy cable, and that's more on the smaller stuff, it'll
Okay.
it'll show that the SWR is better than what it is because the cable is absorbing it and you're not seeing the reflected power back.
Power's not coming back, so even
Leverage.
though the reflective power went down, the reason it went down was not that much got to the other end.
So you got them all?
There was nothing to reflect.
Dave, you got all the readings?
I did.
Okay, we're gonna switch out. Yeah, we're gonna use Mark's, it'll be 125 foot of, the DX. 400 max.
That's the extent.
Yeah.
That's
This
one.
What's the RJ out? Just the first one, just a couple of feet.
Yeah.
On the first one, two jumpers.
Here.
Oh, that was 2 feet, and then the other one was 125.
Yeah, yeah. So that was showing us what we were getting on the radio, a little bit of loss through the jumper. So we'll see what the difference, so this is supposedly a little bit better coax. But again, this is same thing, it's 125 foot of
The critical one's radio check. Okay. Sorry, it wasn't, yeah. This is still fixed on the.
And we'll do the same thing, we'll go to 2 meter. We'll do 2 meter first,
Hold on.
No, still 100 foot,
same 125 foot.
125.
So I did, this is RGA VX 400 max.
That should be.
The other one was the RGA.
8U. I didn't have any of the old stuff. Okay, so this is the 400 max. We got 30.1. SWR is 1.06. Reflective power is 0.06 or 2 meter. And this is the coax. This is the coax I'm using for my my GP9. So that's the other thing. If you lose power, if you have a antenna with a higher gain, that helps.
Makes it up.
Correct.
Anybody know what's happening to that power that you're losing?
Heat.
Exactly.
Okay. Ready for 440?
440.
Okay, 19.15. Reflective power is 0.07. SWR is 1.17.
We gained 6 watts.
Yep.
Now, what's the difference in loss on the specs between those two?
They're awful. They're all close. And actually, I've got some Potaflex down here, which is smaller, thinner. We're gonna throw that in so you can see. And again, that's a little higher. Well, actually, we need to do the 8X, right?
Yeah.
Yeah. And that'll show a big difference. So on the 400 max at and again, this is listed for 440 at 100. So on 2 meter, it's 1.8 dB loss, but at 440, it's 3.3.
So what was the regular AU?
The 8U at 2 meter was 2.2, and it's not listed for 440.
That 1.8 and 3.3, you said, is that per?
100 foot.
Yeah, for 100 foot. When you look at all the specs on the cable, it's usually per 100 foot.
You gotta specify.
I brought along a table that does have it for 440. And they're listing it as.
8U?
No.
Yeah, 8U, but the max 400 does list this. It's on 3.3 dB. Yep. Okay, which one did I got off? What did I give you? 240. So I haven't done 440 yet,
You did 440.
and I did 2 meter on this.
You did 2 meter and 440.
Okay.
On the 8 max.
So now the interesting thing is, there's a lot of people that'll run the small stuff for 2 meters and definitely on 440, and you'll see the big difference.
Yeah, it's hard to see. What I'm about to ask and what I was. You're one of the people that. Not so much on 6 meters.
And if that stuff's given up as heat, why do you suppose it becomes heat? No, you're right, it's work. Times time, which is energy. It takes, with a bad coax, transmitter has to work harder to get that down there. And that is what causes the heat.
So is the heat in the transmitter or in the coax?
It's in the
On the transmission line.
So the heat is in the coax.
You get some in the final amplifier as well, because it has the work.
So you should be able to take, one of those points and.
No, I disagree with it. I would disagree with it. I think the transmitter is working the same no matter what,
We're only gonna use 100
because it's a signal generator.
Right.
Because you're only running.
If this is truly lost,
I forgot my.
the loss is in the element, which is the coax. So to prove that, you have to somehow measure the temperature and see the difference. Exactly.
See how long it takes for the.
But you don't see a big difference, even on 100.
Different coax.
Well, not the fan. See what the temperature of the coax. Yeah.
At the time, heat down is the same than it is all out here. It's not.
I see what you're
Have the
saying.
heat, you gotta.
Surprised he doesn't have
Okay, guys. This is RG8X. So again. For HF, a lot of guys use this for HF, which is fine. The loss,
2 meters is high.
but using this on 2 meters and 440, it's, yeah, it's not even listed for it. So we're gonna do 2 meters first. We still good or no?
Hold on a second, I picked the wrong cam.
Oh, yeah, HF.
It's.
And this is only 100 foot, so 25 foot less.
There we go.
Right? Okay. 18.7. Reflected is 0.03, SWR is 1.05.
By the way, notice something that's really important here. The SWR looks really good, doesn't it? Okay,
Good as dummy load.
but yeah, but the power loss is pretty significant.
Yes,
And that's why the SWR looks good. Part of the reason. why it's good.
You guys ready for 440?
Yeah.
Oh, yeah.
8 watts.
Like your hand.
8.16, reflected 0.03, and SWR
Wow,
is
and you're wondering why you keep
1.13.
crying.
Yeah.
But look at how good that SWR looks.
And again, that's where Mikey had, and it's not, this is not that far off from the LMR 240. But LMR 240 does list that it will work on 440, but the dB loss,
Horrible.
yeah, it's horrible. And like I said, putting in the bigger, better coax made night and day on his receive and transmit.
What was the dB loss on that, is that on the table or not?
Yeah. Give me a second. 8X. So it doesn't list, so for 2 meters, it's 3.8. So it's a little better than half, but it doesn't list 440, and that's where you saw. And the longer the run, the worse it's gonna be.
Yeah, the specifications are usually dB per unit length. And the unit length is usually 100 feet.
This was a great presentation.
Frank, can I share my screen now with the?
Yep.
While you're doing that, the last coax, we'll let you do yours. I'll show the Photoflex, which is a higher end coax.
Okay, now we are looking at Mark's VNA screen. Isn't modern electronics amazing?
What we see here is a graph showing the signal loss from this cable from a starting point of 3 megahertz up in the upper left-hand corner down to the lower right-hand side representing 450 megahertz. At 3 megahertz, we can see the actual cable loss is it's about 4.45 decibels, about a half a dB at 3 megahertz.
And that's RG8X.
RG8X. At 30 megacycles, 30 megahertz. The loss goes to about 2.5 decibels,
Not bad.
which is right here. The next marker is at 144, 145 megahertz, the 2 meter band. And there the loss goes to about almost six decibels.
Wow.
That's a low loss.
That's right.
What is that, a quarter?
Find that good cable.
6 decibels is a quarter.
Well, 3 dB is half hour, 6 would be
One
half
quarter.
again.
Yeah,
Again,
so that'd be 1/4 of the power is getting
one
through.
quarter power is getting through.
And then at the end of the range, down here, all the way down here to 450 megahertz. The loss is measured at 10.7, about almost 11 decibels. Now, keep in mind, this chunk of cable that I have is a little bit longer. It's 150 feet of cable. Where Ed was demonstrating just 100 feet of cable. But still, you can see how dramatic the loss is as the frequency goes up and the quality of the cable is less. It's RG8X.
Who's DX Engineering?
Yes. Now I have a confession to make. I suggest you don't use RG8X at 440 megahertz. You probably shouldn't use it at the 2 meters either. But you know,
Unless the run is about this long.
Yeah.
Right. You know,
That one quick run.
now I've got a length of 400 max cable that I intend to use on my VHF UHF antenna, but I haven't installed it yet. I am still using RG8X on my VHF UHF antenna. And guess what? It works. But I'm putting like 50 watts into it and it's working like an HT. But, you know, my HT works also for the local repeaters.
So what's the gain of your antenna?
It's it's not the 9, it's,
The 6?
I think it's a 6, maybe it's even 3. But the point is, use the best coax you can afford because it's money well spent.
Money well spent.
My common rule of thumb is in my shack, interconnecting, and you start building a shack, you're gonna be amazed at how many interconnecting cables you have, okay? But interconnecting cable, I'm using ABR 240 for all my interconnection, except for 2 meters and above. Anything that's HF is ABR 240. Why? By the way, Kevin Goodman, who is a good friend of mine, had a really nice shack set up, and when I tore it apart, everything was 8U, and that's big, heavy coax. He had jumpers this long, he had jumpers that long, and they were all hand soldered RG8U. Okay, the big, heavy coax, and his rationale was, and he was running a kilowatt amplifier, and his thought was, if I'm running a kilowatt amplifier, I got to have heavy duty cable on everything, right? Well, the only thing that was a kilowatt was the output of the amplifier. Everything else, and that, by the way, the receive side doesn't care anyway. Okay, but the point is my general rule of thumb is ABR 240 for anything that's HF in the shack. Okay, if it's a long run outside, I've got a 90-foot run to my gap tight and vertical. It's hardline. Now, did I buy that hardline? No, somebody gave it to me. Okay. And I happen to be able to cobble together some cheap connectors for it, but it's hardline, and I don't worry about loss on hardline. Okay, my UHF VHF stuff, the good LMR 400 or ABR 400, that kind of stuff. Even the 6 meter antenna I just put up, 400. Now 50 megahertz is right on that kind of dividing line between HF and VH. It's actually considered VHF. And I figured the hell with it, I'm putting in the better coax. I didn't put in the ABR 240. Now, some of my other smaller antennas for HF outside, if it's not a long run, 240 is fine. In fact, you'll see at field day, we're running a lot of 8X. 2/3, 3/4 of what we're running at field day is 8X. And it works.
So let's
Go back to that.
yeah, I got one more So there are
Oh,
some
you know what?
high-end coax.
We gotta unsure you.
Anything I could do?
So this is M&P, Messi and Poloni. This is actually Podaflex, and the reason, huh? Oh, well. Anytime we put antennas, you guys notice, I always run the bigger stuff, because I know you lose power. I want everything out. So I wanted something that was a little bit smaller, a lot lighter. This coax is triple shielded. It has some pretty good specs, and we're gonna see how it comes out. So it was it worth the money that I spent on it?
And it's yellow.
Well, this is direct bearing. It's made for multiple.
They have several different colors of shield.
Yeah.
Is that flex? This
This is
Ultra
Podaflex. Yeah. Yep.
What's the band radius?
It might be 5 inches or something like that. That's why they give you this. So that's the other thing too. And we have some here. I don't know if we want to take and bend one of them and see what it does. But let's you ready?
I'm ready.
So this is 2 meters, 26.5.
How many feet of coax is
That's
that?
100.
So we got less power coming in the better coax.
But it's still, well, we'll see when I go to 440.
That's.
You got it all, Dave?
Yeah. This is what now? This is meters.
This is 100 feet of Podaflex.
That's why. Yeah, I know.
Okay, ready? So it's better than Nadex, but it's still, there's a considerable loss even, and this is actually listed for 440. So it's 18.3.07 with 1.7.
No, 1.17.
Yeah, 1.17. I'm sorry, I'm looking at it. So when I look at this coax at 2 meter, it has a dB loss per 100 feet of 2.1. At 440, it has dB loss of 3.7. So again, that's why but again, this is definitely better than 8X. So again, if I cut it in half and I'm only running 50 foot, it's not going to be
Bigger loss.
correct. So David, out of all the coax, the max 400, which one won up?
This is our.
The M&P, this one right here?
No.
No,
No.
which one? You were
Oh,
right now.
Something flex.
The 8X 440.
Ask her. I forgot.
Oh, the max 400.
Yeah,
Yep.
That's the best one. Well.
What was the second one? Because when I looked at this, this was comparable to RG 213, and that's I said, well,
at 440 you want it, or it's,
yeah, 440,
the 8U is 13.54.
and this was 18. So this still beats it.
Yeah, still beats
By 3
8U.
watts.
So it's lighter, it's thinner.
More flexible.
Well, what number is it?
This is Podaflex. So it's
It's what M&P specs for portable operation.
Yeah.
No, that's not the question.
It's a different company.
Yeah,
Messi and Poloni is like really, it's like the Rolls Royce of coax supposedly.
yeah, it doesn't have a number, so I'm asking.
that's what they call it, M&P Podaflex.
Podaflex.
Podaflex 7.
Oh, good.
Yeah. And they make a whole bunch of other coax.
You buy that from
Gigaparts. Yeah.
I think they're
Now-
doing it itself.
Right.
There's one thing I remember not that long ago, a few years ago, Dave Brett put an article in our newsletter. Okay, about SWR and how it impacts the receive signal on the other end. Okay,
Lighter.
And we're recording this, so I guess I might as well turn this around.
So if I'm out in the field, it's.
Dave did this really neat article about if you have this much SWR with 100 watts, this is how much power ends up at your antenna. Okay. And then he took the power that was at the antenna and interpolated it into received signal at an S unit at a remote station. In other words, who's receiving your signal? So you're putting out 100 watts and you only get 98 watts or 90 watts to your antenna or whatever. And then the SWR starts changing. How does that change the received signal at the station that is trying to receive you? Okay. And Dave kind of blew my mind because I always thought, oh, you know, I got to get my SWR down really low and blah, 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 blah. And the answer is, no, you don't. As long as the transmitter is happy, the difference between 100 watts at S9 at the receive station and 50 watts, what do you think the S signal is at 50 watts versus 100 watts? S8, if you're lucky. Okay, it's one S unit. And who the hell can hear the difference between one S unit? Now, you might be able to hear the difference. You might be able to hear the difference if it's S2. Okay, and it's a DX station. All right, and it's coming halfway around the world. But how many times are we doing that? Not that often. Okay, so this idea of SWR and power out is all pretty relative when you start thinking about what ends up at the S unit side of the received signal and whether they hear you or not. And the real bottom line is, do they hear you? And I'm here to tell you, I never owned a 100-watt radio for probably 15 or 20 years. I worked QRP. The first HF I ever did was all QRP, 5 watts. Plenty of people heard me.
Okay, is this the part where you take the yellow cable and?
No, I don't think so. I'll maybe crib this one. I didn't know if Mark wanted to do it on his, you know, so another way to check coax is, you know, if you don't have, an NOVNA, there's antenna analyzers. But the other thing that, a lot of people forget.
No, it's right here. It says stop recording.
Oh, okay.
And anytime I put a
You're one
connector
step ahead of
on,
me.
it's a standard, DVM.